Let's graph the linear inequality in problem number 3. 2x minus 6y is greater than or equal to 12. Step 1. Convert the linear inequality to slope-intercept form if needed. Here, the y is not isolated, so we need to convert this linear inequality into slope-intercept form by solving for the y. We will start out by subtracting 2x from both sides, leaving you with negative 6y is greater than or equal to, these are not like terms over here, so we have negative 2x plus 12. To solve for y, we need to now divide the whole inequality by negative 6. And remember that because we divided by a negative number, that this will flip the inequality. Negative 6y divided by negative 6 equals y. We flip our inequality from greater than or equal to a less than or equal to. Negative 2x divided by negative 6 equals a positive 1/3 x, and positive 12 divided by negative 6 equals a negative 2. How did we convert the linear inequality to slope-intercept form? To convert this linear inequality to slope-intercept form, we used our inverse operations to solve for y, and remembered that when we divide by a negative number, that this will flip the inequality. Step 2. Graph the boundary line. The boundary line will cross the y-axis at negative 2 and has a slope movement of up 1 and 3 to the right. Up 1, 3 to the right, up 1, and 3 to the right. And our boundary line will be a solid line because this is y is less than or equal to. How did we graph the boundary line? We graphed the boundary line by using the y-intercept and a couple of points from the slope movement, and then determining that it's a solid line because it's an or equal to type of inequality. Step 3. Shade the solution region. We look at the isolated y and the inequality. Y is less than or equal to. Because this is a y is less than type of inequality, the solution region is below the boundary line, so we shade below the boundary line. How did we shade the solution region? We shaded the solution region by looking at the y and the inequality and using our rule that if y is less than, then we shade below. You are now ready to graph the linear inequality in problem number 4.